Good morning. My name is Sponseni David Kanyile. The student number which is 115305783. Today I would like to do my presentation on the transportation engineering, pavement and geometric design projects which we've been given by the lecturer for semester 1 2023. The aim of the project, um, we've been tasked as a student to upgrade or design a gravel road or a road that has reached its life to a standard surface of two-lane road. I am expected to generate the final alignment by utilizing commercially available geometric design software like your civil designer and your AutoCAD. And for this project, I've opted to use a civil designer, a student version. The design will include the following: alignment design for at least 3 kilometers road, but not more than 4 kilometers. A detailed manual calculation of one horizontal curve and one vertical curve. A completion earthworks design and mass hull diagram. Conceptual design of a stormwater drainage system, e.g., like for an example, like your side drain or your capped inlets or your vertical profile for like your culverts. Okay. For this project, I have chosen since the lecturer has given us a freedom to choose any of the road that is within our country. The road that I've chosen for this project is Fontaine Road, which is within Jacobsdal town, west of Bloemfontein and east of Northern Cape provincial border. This small town was established in 1859 on the farm of Carl Fontaine. The town was named after a farm's owner, which was Christopher Johannes Jacobs. It actually obtained its municipality status in 1960. At the time, it was called Jacobsdal District, and it was one of the largest districts in Orange in Free State. Okay, it is clear that the regional route has exceeded its maximum span life. Hence, there are visible cracks in the pavement structure. I've actually attached a picture on my project for detail purposes. And as a civil engineering technologist, I've been approached by Letsemeng municipality to produce a design of the road that I've chosen, which is Modern Fontaine Road, from chainage 0 to 3,700 meters. Now, before you design a road, you need to know or estimate the number of cars that uses that road in a day, in a year, or in a month, and that will determine the the design that you need to design. Those information will actually give you an idea of a design of what is expected of you to design. And after a study that was conducted before the information obtained from the municipality, which assisted the design of existing pavement structure based on ADT of 650 vehicles per day over an analysis period of 20 years. The recommended pavement class for this road is ES1 0, 0.31 times 106 E80, and the road classification is shown on the table below, which was attached on the report. Okay, since we now know the the actual road that needs to be designed, the number of vehicle that will be designed for. We now need to know the site locality, um, which I've stated before, which is gonna be the Modern Fontaine Road, and and the design speed that we've been allocated for this road is the 80 kilometers per hour. And the proposed road is actually located on the portion of 146. I've actually attached the the map on my report. The road is located on 146 Farm, Jacobstown district. The area falls under, which I've mentioned before, Letsemeng municipality in Free State. It connects the community of Jacobsdal to a very important services such as schools, clinics, hospitals, and public transport facilities. Now, before you design the road, you need to do your research, which we have started with to estimate the traffic count. We now need to look at environmental issues around the area, which might also be considered on the design. And now we have to look at the environmental side of that area. And it shows on the map, it shows that the site lies in a protected area, and an environmental specialist has been appointed to advise on the impact of the matters that will arise from environmental legislation. Now we're gonna look at the topography. And the site is actually located towards the western boundary of Free State Province, between 1702 and also 1740 above the sea level. And the area represents the average slopes between 2 and 6 degree. The surface morphology of the site is highly undoubtable due to the presence of variety borders and also erosion of structures. The local landscape is seen to have a basin, like a structure, with the southern portion of the site being a lower portion and existing pipes of basin. The surface of the site hosts a small and localized area where the surface morphology and topography has been altered through on going human. We now going to look at the climate, which also falls under the environmental issues. We have actually looked at the topography, and now we're going to go to the second part of environmental, which is the climate. Um, um, Now we're going to look at the actual area. It actually received a rain per year of 265 millimeters, with the rainfall occurring during autumn. It received the lowest, which is 0 millimeters in July, and the highest of 54 millimeters in March. The average midday temperatures of Jacobsdal ranges from 18 degrees Celsius in June to 31.8 Celsius in January. The region is the coldest in June when the mercury drops to a very cold, which is 1 degree Celsius on the average during the midnights. Um, the climate of an N value um, for the area is between 9 and 10, indicating that the principal mode of weathering is within the regional setting of the physical and mechanical decomposition of parent rock, and rather the which can be expected in an area of a wetly climate. We can now look at the drainage, which is the third part of um, um, climate, climate, climate part of the third part of the climate. So due to the slope, the sides will drain mainly by means of a slope or low energy surface run off that is should flow with storm water and eventually flowing from the high rise area in the north and east towards the drainage structure in the south. So, as I mentioned before, that the area is like a basin structure, and it will definitely the catchment of the runoff will alter and it will flow directly to the south. Now we're gonna look at the site status quo investigation, which will include the water recirculation and also the sewer recirculation. For water recirculation, we've noticed that there's an orange rights water line that runs along the Modern Fountain Road, and the pipeline is is conceptual by pipe. Markers and markers and valve chambers were actually portrayed on display alongside the Motor Fountain Road, and the neighboring property in the same street has meter box outside the fence, which indicates the availability of municipality water connection in the area, which means the pipes do exist, which means we need to take that into consideration when we're doing the layer works, when we're doing the trenching, when we're doing the culverts, all of that. That will include the sidewalks in terms of the stormwater pipes and everything. So we need to take that into consideration so that we won't distract or disturb any pipe that exists, especially that falls under the municipality. Okay, we're gonna look at the sewer now, which is the form part of our investigation. There was no sign of formalized sewer recirculation in the vicinity of the proposed development, but we during our investigation or our research we met with or we sat down with one of the residents nearby, which we had to confirm that there was no formalized sewer circulation, but the way he suggested that they used or he mentioned that they used septic tanks in the area, and the nearest possible municipality connection that will belong at the corner of Monumental Road and also R1 R114, where there is existing complex service by municipality. Okay, since now we have done our research and we have looked at we have done in terms of we know now the expected traffic count or the traffic that we expected on the road. We have looked at the environmental side of the road, and also we have looked at the the site status quo of investigation that included the water recirculation and also the sewer recirculation. So now we can now design or consider our design. So now we can look at the standard of design that we're going to use for this particular road, which is Fontaine. And we have we have decided to adopt the following um, standards, which is in line with the municipality, the local municipality, and those guidelines included the the TRH 4, TRH 17, Sandal manual, and also very important, the um, the the design standards and the norms of the Letmeng municipality. The following guidelines I've also listed on my project, which is the structural design of flexible pavement, um, and guidelines for geometric design of urban roads. And also, since we're going to be dealing with drainage as well, I've also included the drainage manual, which falls under Sandor RSA, and also the land and the land acquisition guideline for consulting engineers. Those are the guidelines that will be used to design or adopted um, um, for this particular or proposed road. So now we can now look at the pavement design, which is we after we have looked at the standards or the guideline that will be used, we can now actually design the actual road, which is which we need to now look at the tables that we're gonna use, which falls under the TRH 4, to classify the pavement and also assume the design life of between which will tell us the design life, which I've actually stated on the reports that the design life is between 15 to 20 years, and the pavement class that we assume, which I've mentioned on the previous slides, is ESO, with and with the with 650 vehicle per day and per lane. The proposed layout works are as follows. I've actually the lecturer has given as stated on the project brief, um, the the proposed layers. The flexible pavement is a pavement constructed of material enable the total pavement structure to flex and deflect considerable under traffic load. So this basically what it is saying that is that the pavement that we need to design has to be um, we or, able to withhold or able to endure the traffic load of the vehicle that will be traveling on the road each and every day. And construction material mostly we used are soil, natural, and crushed gravel, and also bituminous material such as pavement, include roads and gravel roads, and also bituminous paved roads. Over here is that the material that will be used on layerworks are material that will be tested, natural, and also crushed gravel, which is a norm whenever you're dealing with the layer with sorry with the layer works. And okay, now we're gonna look at another parts of the road design, which is very important as well, because if you can't drain water, definitely if you cannot control water or storm water, then that road, the water will take over and the road will easily get damaged if the water is not controlled. And for stormwater proposals, we have looked at the design standards and the norms of the city of Jacobsdal in Letsebeneng municipality, and the guideline for, and also look at the guideline for human settlement and planning and design, and also the GDID manual, which will be used as a basics for this design. Now we're going to look at the vertical alignment of this design, and we're going to look at the constant rates of change of bearing, and also the um, the 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 differences between being virtual and unplottable in an event within the level of accuracy to which the pavement is typically constructed from the general form of parallelopic function. The following design is chosen. Okay, the following design is chosen to design for a road as per road, which is 40 meters surfacing and 150 upper selected sublayer, which needs to be compacted to 98 percent, and also look at the 150 base layer G5, which needs to be compacted into 97 percent, and the last one which needs to be 150 and also be compacted to 93% of mod extra. And 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 this is the current condition of Fontaine Road. Um, and before everything was conducted, we had to look at um, the condition of the road, which I doubt had layer works before. And and according to which I've mentioned before, that the study that was done, uh, the study that was done on the according to the study that was done um, on the actual road, we actually discovered that um, the road that was used before, it's it was it didn't have layer works. Hence, we have to do the study, and also in terms of the estimating the present traffic, and also look at the design itself of the road. For this road, I've actually used the the civil designer software, which allows the design and analysis of the complex roads, earthworks, sewer, water, stormwater, and networks, and also at all times upholding the realistic of model in which relevant structure elements and also geographic associated. So, as I mentioned that before, that for this road, particular road, I've decided to use the civil designer, which is a student version, which I was trained with during my in-service training. So this is the actual road that was proposed, the road design that I designed, and this is the final layout, which is the road that will be attached on my report in detail in terms of the long section, the cross section, the screenshots, and also the actual layout of the road. Thank you so much.